Hi everyone, this is Lab 1.2, using various separation techniques to isolate the different components of a heterogeneous mixture. So what I have here, ladies and gentlemen, is a mixture of silicon carbide, potassium nitrate, and trace amounts of copper sulfate. And using two different separation techniques, we are going to be able to isolate all of the individual components of this mixture. Taking a look at our procedure, the first thing that we are asked to do is weigh or mass a 150 milliliter beaker. I have already done that. The mass of the empty beaker was 69.6855 grams. At this point, I am ready to mass my pre-cut filter paper. I've already cut it out. This is filter paper number 1, and its mass is 0.4234 grams. The mass of filter paper 2 0.4010 grams. Okay, so at this point we have done all of our preliminary weighings. We are ready to now obtain our unknown sample. So we need about 20 grams of this. I'm just going to pour it into the beaker, 150 milliliter beaker like so. We're trying to get somewhere around 89 grams, so around 20 grams of the mixture. Use a little bit more. Once again, it does say approximately 80 grams, so if we're a little bit more, a little bit less, that is okay. We are currently at 89.1654 grams, which is good enough. Okay, so at this point we have successfully completed all of our preliminary weighings. We are ready to jump into the actual lab itself. Well, next steps. Take about 40 milliliters of deionized water and dissolve our solid. So I have a graduated cylinder here. It does say approximately 40 milliliters, so I'm just going to try to get to essentially close to 40 milliliters. Go. I went a little bit over, but that's okay because it does say approximately 40 milliliters. So I'm going to dissolve, or attempt to dissolve, my water-soluble components of the mixture. So our first separation here, ladies and gentlemen, is going to be based on the idea that 2 of the 3 components in this mixture are water soluble. Both potassium nitrate and copper sulfate are water soluble. Silicon carbide is not water soluble. So by adding water to this, our soluble components will dissolve and our silicon carbide will be isolated. Now, I'm heating it up here in the beginning to ensure that all of the water-soluble components dissolve entirely. Typically, solutes will dissolve in solvents. Solid solutes will dissolve in liquid solvents at elevated temperatures when the solvent temperature is elevated. So we are simply increasing the temperature of the water to ensure that all of the water-soluble components actually dissolve. All right. While this is heating, we can take a look at our Buchner funnel apparatus. So you can see here, just to test, Bunsen burner tube connected to our sink, which is then connected to what's known as a sidearm flask. When we turn on the water, there is a suction of air out of the Buchner funnel, which essentially creates a vacuum inside of the sidearm flask. That will allow us to filter out or to filter quicker than simply just using gravity, because water will be getting sucked out of the bottom of our Buchner funnel. Here is the actual Buchner funnel itself. So while this is heating, like I said, we are going to get filter paper number 1. We're going to put it into the Buchner funnel. We want to make sure that all the holes on the Buchner funnel are covered, so that way none of the silicon carbide escapes and goes through the filter paper. So I'm just pushing the filter paper down so it's covering and kind of covering all the holes and touching the sides of the Buechner funnel itself. At this point, before we get started, before we actually filter, what I'm going to do is I'm going to turn this on, and I'm going to spray a little bit of water in here. So we can start to see the water getting sucked through to make sure that we are getting suction. Also, this helps in making sure that the filter paper is stuck to the sides of the actual funnel itself to avoid any of our silicon carbide from escaping through the holes in the Buechner funnel. So at this point, this has been heated sufficiently, and what we are going to be able to do next is turn on the Buechner funnel and isolate our silicon carbide. Now I am going to have to pour slow here to avoid losing or over pouring and allowing the silicon carbide to fall through. So this process is going to take a little bit of time here. Feel free to speed up the video if you would like. Now at this point, ladies and gentlemen, I have a lot of the silicon carbide. Let me come around and show you a little bit closer. A lot of the silicon carbide still stuck to the beaker itself. There's still a little bit of liquid in there, but essentially most of the liquid has been poured through. You can kind of see the clear blue filtrate solution down there at the bottom. Now what I'm going to do to get the remainder of our silicon carbide out is spray deionized water into the beaker and kind of allow it to flow out and onto the filter paper. I am running low on deionized water, so I'm going to go fill up in the stockroom real quick. Be back shortly. Back. So let's get the remainder of our silicon carbide onto the filter paper. At this point, our beaker is clean and free of all silicon carbide. And now we are simply trying to get as much water off of the silicon carbide as we can before we take out the filter paper and allow this to dry until tomorrow. Okay, let's take a look at the end result, ladies and gentlemen. So, after going through this process, what you'll see is we have successfully isolated our silicon carbide. All of that kind of gray, dark matter on the filter paper here is silicon carbide. So we were able to isolate all of that simply through filtration. So due to the fact that this is still wet, we cannot get the final mass today. So what I'm going to do here is I'm going to push this over to the side. I don't know if you could see that. I have a little drying station set up right here. I am going to use a scoopula to get one of the edges of our filter paper up. So I'm kind of just pushing up the edge of our filter paper. So I can grab this and put it on a paper towel to dry until tomorrow when we can get the final mass reading. So we're just going to leave the filter paper on this paper towel and we will get our final mass measurement tomorrow once it is dry. If we were to take the mass right now, it would be artificially too high due to the fact that there is still water present in or on the filter paper as well as on the silicon carbide itself. Okay, so that is step one. We have successfully isolated one out of the three components that is in this mixture. We now have to work towards isolating potassium nitrate from the copper sulfate that is in solution. Now, what you'll notice here about what is left over inside of the sidearm flask, move this and show you. We have this blue clear solution. Okay, so this is telling us a couple things. Number one, it's blue because there is copper sulfate dissolved in it. When copper ions are in water, they turn the solution blue. Number two, it's relatively clear. You don't see gray floating particles in there because we successfully isolated all of the silicon carbide. So what we're going to do next is pour this into our original 150 milliliter beaker. And at this point, actually before we start to boil, we are going to add 15 drops of 6 molar nitric acid to ensure that the copper sulfate remains in solution. Grab 6 molar nitric acid, grab plastic pipette, 15 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Extra. Keep that down the drain. Okay. So, at this point, we are going to boil off some of the excess water here. So at this point, we are now moving on to a different separation technique. It's known as fractional crystallization. This is the idea that different ionic compounds have different solubilities in water at different temperatures. So what we are going to do is we're going to use the difference in solubility between potassium nitrate and copper sulfate to isolate the remaining crystals that are present in solution. And in order to do that, we're going to need to boil off a lot of the water that is currently in solution. So with that being said, I'm going to need to get this water to its boiling point. It's going to take probably 5, 6, 7 minutes. Feel free to skip ahead in the video right now because all we're going to be doing at this point is watching the water boil for, like I said, between 5 to 10 minutes. So if you would like to skip ahead, feel free. This is getting hot, ladies and gentlemen. 5 minutes may have been a bit of an underestimate. You might want to skip ahead 10 minutes at this point if you are still watching the video at normal speed. Getting close to a boil.
nice roaring boil at this point. While this is going on, I'm going to retrieve my ice cold deionized water. I have it sitting in an ice bath in the stock room right now. Place my ice cold deionized water inside of our ice bath right here. Also going to get my 12 milliliters of deionized water ready. 12 milliliters, sometimes the squeezing technique is not bad. Be patient. It's got to boil. Patience. Still boiling. Getting closer. Getting close here, ladies and gentlemen, so I'm going to reposition myself so we're ready once we start to see some crystals appearing on the side of the beaker. Close, ladies and gentlemen, we're close. Maybe about 2 more minutes or so. While this is getting ready, I'm going to reassemble my Buchner funnel so this is ready to go. be careful, ladies and gentlemen. Make sure that we don't boil too much off. So I'm looking at it fairly closely here. Looking for the presence of white crystals on the side of the beaker. We're not seeing any quite yet, so we're going to continue to boil off water here. But we are looking at it very carefully. Come around to the other side. I don't want to stick my face directly over it. But taking a look at the other side here. We're down to about 30 milliliters of water. We started with 100 milliliters of water. So we've boiled off about 70. And we should be getting fairly close to the point where we start to see potassium nitrate crystals come out of solution. So we are getting close. Usually happens right around the 20 milliliter mark, so we got about 10 more milliliters to go. All right, I'm starting to see crystals on the side of the beaker here, ladies and gentlemen. So we have successfully gotten our potassium nitrate to come out of solution. So I'm just going to roll this along the edges here. I'm going to add my 12 milliliters of deionized water to try to get all of the white crystals on the side of the beaker. I'm trying to get them to redissolve in our solution. Just rolling the liquid along the edges of our beaker. Try to get the additional white solid to dissolve. So now at this point, the procedure says for us to wait until this is cooled off to room temperature before putting in the ice bath. This video is long enough, so to expedite the process, I'm just going to put it directly in the ice bath right now. I'm going to take out my deionized water that is in my ice bath. I'm going to scoop a little area to safely put this down in our ice bath. I'm surrounding the beaker with ice cubes as we speak. And we are now going to let this cool for about 10 minutes or so. We want to leave that undisturbed. We are cooling off our solution. So the substance, or potassium nitrate, it's not the substance, potassium nitrate, which is going to be less soluble than copper sulfate at lower temperatures, should come out of solution. So once again, we are separating our potassium nitrate and our copper sulfate through a process known as fractional crystallization. And this process takes into account the idea that these substances have different solubilities at different temperatures. So we'll be able to isolate our potassium nitrate because it will be less soluble than our copper sulfate, allowing it to come out of solution. So once again, at this point, we're going to be leaving this in the ice bath for about 10 minutes. If you would like to fast forward this video, feel free, because we're probably not going to look at this again for about 10 minutes. 10 minutes, fast forward.
Still waiting for that to cool off. Take a look at how we're doing here. Still needs a bit more time here. Maybe fast forward another 5 minutes.
let's take a look at where we are at. Okay, ladies and gentlemen, we have gotten our crystals to come out of solution. You can start to see the crystals forming there on the sides. So we are going to get our Buchner funnel apparatus set up. And we are going to be able to filter and finally finish up this lab. So to get our filter paper ready for our second filtration, we'll be using, dry out the inside of the Buchner funnel first. It's still wet from our first filtration. And we're going to use some of the cold deionized water to ensure that while we are filtering, the potassium nitrate crystals do not redissolve. That's why we're using cold deionized water. And what I'm going to do here is allow the deionized water to sit and kind of cool off the Buchner funnel for about a minute before turning on the water and allowing the liquid to flow into our flask. Do not need the hot plate anymore, so I'm going to move this. All right, let's filter. First thing I'm going to do is try to dump all the excess liquid down. We are left with crystals at the bottom of our beaker. I'm going to use my stirring rod and rubber policeman to move around these crystals, try to get them out of my beaker. Now, there are still some crystals at the bottom of our beaker. So I'm going to actually hold on to this tomorrow. I'm going to let this dry over in our drying station as well. And
take a look. You can see the potassium nitrate crystals that are in there. Now, what you'll notice is, and we'll take a look at this again tomorrow, there does appear to be a little contamination in there. There does appear to be a little gray in there. And I think that can be explained by the fact that I used the same beaker that I started with, that I put the original mixture in. So it's possible that I did not get all of the original silicon carbide out of my beaker originally. Now, similar to our first separation, ladies and gentlemen, we are going to have to let this dry overnight. It's wet, so its mass would be inaccurate if we took the mass right now. So I'm just going to pull this out, leave it on the filter paper. Leave the filter paper on the paper towel to dry. You can move ourselves. You can kind of now see the drying station. And tomorrow, we will be able to get our final masses so we can calculate the percentage breakdown of our mixture. What percentage was silicon carbide, what percent of the mixture was potassium nitrate, and what percent of the mixture was copper sulfate.